Question 6a. So this question started with maleic anhydride. This one. After reaction 1 is formed the maleic acid, so with the 2-carboxylic acid, and after that reaction 2 to form this DiO. Obviously is an oxidation. Part 1. Maleic acid, this one, this acid, reacts with ethane 1,2-DiO. At least you need to know how the ethane 1,2-DiO looks like. Okay, so is this one. The this CH2OH, CH2OH. So this DiO here. And draw the section of this polymer, show one repeat unit only. This part no need to draw, just to show you how to form this polymer repeat unit. So this one is the maleic acid, okay, with the 2COOH. The COOH will react with the, of course, the OH from the DiO. So it will undergo this condensation reaction. So H2Os will remove and the new bonds will form, the CO bond. So it will form this this bond, ester bond. And what you need to do is you just need to remove H here and remove H here and add one bond. Add one bond, and here you add another bond, right? So remove the H, remove the H. So eventually you get this polymer chain with one repeat unit. Remember to draw the bracket and the tails here. Part 2. Identify the suitable reagent and the conditions for reaction 2. This one is to form the DiO. The double bond open up, form this DiO. This one is in AS. Is the co-acidified or co-dilute acidified camino4. Right. So this one is to oxidize the CC double bonds to form DiO. Part B. Compound U can be formed from the tartaric acid in 2 steps, as shown in this figure 6.2. Part 1. Suggest the type of reactions occur in step 1. Okay, step 1. This one you need to observe carefully. This tartaric acid react with propanol. Okay, so let's say now the propanol is here. So the 2 hydrogen here will remove together with this O. So all gone to form the H2O. Then the oxygens here will form new bond with this carbon, right, to form this compound. So this is what happening in the step 1. So suggest a type means you can put either one. Of course, condensation is always the better answer, right? Or you can say dehydration because remove water, or elimination. Okay, part 2. U can act as a bidentate ligand. Okay, this is U. A bidentate ligand because of this carboxylate. So because this one it has the this lone pair donor. So on the oxygen here. So on the oxide COO negative. So therefore it can be a bidentate ligand. So explain what it means by a bidentate ligand. Very easy. A species that contains 2 lone pair of electron, and it will form dative bond or dative covalence bond with the central metal ion. Okay, that's a bidentate ligand, means 2 lone pair and form the dative bonds or 2 dative bonds. Okay, part 3 completes the 3-dimensional diagram in this figure 6.2 to show the stereoisomers of this copper with the 3 bidentate ligands here, the U, with 4 negative charge. Okay, you can just use this one to represent the bidentate ligand, the U. Okay, very easy. Because it's 3 only means you need to draw the octahedral complex. Because this one stereoisomers means optical isomer, you must draw the mirror images. Okay, so let's say now you draw these isomers, the copper with the 3U, right? So remember to put the negative charge here. Copper is 2 plus, the U is 2 negative. So overall is 4 negative. When you draw this, then you need to draw the mirror image. Make sure the position is follow. So the U must be this position, and this U must be this position. It's like mirror image. Okay, and this U, okay, will be in this position. Right. So this one very easy. Okay, it's 2 marks here. Okay, part C. A student analyzed an aromatic compound X, okay, which the molecular formula is a C8H8O3 using the NMR spectroscopy. Figure 6.4 shows the carbon NMR of a sample X dissolved in the D2O. Okay, so from this carbon NMR, we can actually know how many carbons environments there. So total there are 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So total 8 carbons environment, and this one you have to be careful. So all these signals here actually is the benzene, is for the benzene carbon. If you check the table, you know the range. When the chemical shift is from 110 to 160, so it's possible to be the carbon in the benzene ring. So from this carbon NMR is most likely telling us these few carbons means these 6 carbon, it might be the carbon in benzene ring. And these 2 carbon, if you check the table, is the carbons that next to carbonyl. Okay, this one. And this is the carbons in the carbonyl group. So this is the info that you can get from the spectrum. Okay, now let's move on to the other part. Okay, separate samples of X will analyze using Proton NMR. And after the analysis, so this is the numbers of signals produced. With the deuterated solvent, it forms 6 signals. With D2O as a solvent, suddenly now it's lesser. Now it becomes 4. Means in the X, it might be the OH group or the COOH group in there, because it might undergo proton exchange with D2O. So means if there is OH, then it will form the OD. OD will not be detected in the proton NMR, and this carboxylic acid also is from COOD. So OD it will not be detected in the NMR, proton NMR. So means it's kind of like telling us in the X it might have 2 OH or COOH. That's the hints given by this part. Okay, identify the numbers of different carbon environment in the X. Okay, just now we already count is total 8. 8 carbons environments, because 8 signals there. Okay, part 2. Explain why X is dissolved in D2O before obtaining its proton NMR. So it's just to remove the signals from the OH or COOH. Means is to make sure or to know is there any OH or COOH group in the X. Right. So from here we know that it's kind of like 2 OH there or COOH, but most likely it will be the OH, because from the molecular formula. Okay, later we discuss that. Okay, now part 3, aromatic compound X. Because it say aromatic, so means you need to start with a benzene ring. Benzene ring already 6 carbon, so means the other 2 carbon is outside the ring. So you have to understand the statements given. So means most likely is a benzene ring with 6 carbon and 2 carbons out there. And this is the most important information. The X will give yellow precipitates when it reacts with alkaline iodine solution. This one is actually telling us it has the methyl ketones there. So means the other two carbons outside the ring, it must be this methyl ketone. And how we confirm there is a methyl ketone? From this signal, this one. Because around 210, okay, we get one signal. This is the carbonyl carbon. So this one is for the carbonyl carbon signal. So it means we are quite sure it's a methyl ketone, not this alcohol group, not the CHOHCH3. Right, this one out. So most likely it will be this methyl ketone. Then roughly we get the skeleton, the main structure already. A benzene ring, is it? A benzene ring with the methyl ketone. So total 8 carbon. And because in this formula there are 3 oxygen. In the methyl ketone only 1 oxygen. So means the others 2 must belongs to OH. It cannot be COOH. No extra carbon now. So means the others part, it must be the 2 OH bonded to the benzene ring. No others option for that. Okay. So and this is a proposed structure. Okay, you can use this one, or this one, or this one, or this one. Okay, why? Because this field structure, it can give the 8 signals in the carbon NMR. Means it will give 8 different carbon environment. Okay, let's count. This one is 1, 2, 3, 4, 5, 6, 7, 8. Because it's not symmetric, so all the carbons, they are different now. It will give 8 signals. Same as all these 3. Right? You get these 8 different signals. Okay, make sure you not really propose these 2 structure. Why? Because it's kind of like a symmetry structure. So let's count. 1, 2, 3, 4. This one also 4, 5, 6. So this compound will give 6 signals in the carbon NMR. Okay, this one also 1, 2, 3, 4, 5, 6. So means you cannot propose these 2 structure. Okay, you can propose any one of this. Okay, and make sure the 2 OH group is bonded to the benzene ring, the phenol. Okay, so this one is the explanation why and how. So there is a methyl ketone group present in X, okay, as is give yellow precipitate with the alkaline iodine. This is confirmed by the carbon 13 NMR, which there is a signals in the range of 190 to 220. Here, again, these signals. This signal is telling us there is a carbonyl carbons there, right? So it's a methyl ketone, not the alcohol. And of course, there is a signal in the range of 30 to 65. It's telling us there is a carbon next to the carbonyl. So it's further confirmed is the methyl ketone. And there are 2 OH group then, because the 2 signals lost after the X dissolved in D2O. We are quite sure the 2 signals it must from the OH, not from COOH. Okay, that's all. Thank you.